Yes. So in reactive intermediates, in your last class we discussed about nitrine. So nitrine complete preparations as well as detection of nitrine, stability of nitrine, and one more is chemical reactions of nitrine. And especially in nitrine, the most important reactions are Hoffman, Curtius, Lawson as well as Smith. And one more last reactive intermediate is here, that is benzene. Benzene, it may also helps in pericyclic reaction. Most important one, it may helps in pericyclic reaction. It is also one of the reactive intermediate. Okay. So benzene is a dehydrogenating product of. It is dehydrogenating product of benzene. It is a dehydrogenating product of benzene. So when benzene loses two hydrogens, that will form say benzene. Suppose here one hydrogen is there and here one more hydrogen is there. If you remove these two hydrogens, so loss of hydrogenation will take place. Finally, there is a triple bond formation takes place. This is benzene and this is benzene. Okay. Now, benzene is it is electrophilic in nature. It is electrophilic in nature. Benzene is electrophile. It is a neutral electrophile. Okay. So benzene is unstable. Benzene is unstable. Formally neutral charged molecule. Formally neutral charge. So there is no charge produced on benzene. So benzene is electrophile in nature and it is unstable fragment or species, and this is formally neutral charged molecule. Benzene is formally neutral charged. Okay. Now, benzene is strained molecule. Benzene is strained molecule. It is actively involved in. Benzene actively involved in nucleophilic addition reactions. Nucleophilic addition reactions and cyclization reactions. So it is very strained molecule. They want to release their strain. So that's why they undergo addition reactions and cyclization reactions. So two common reactions are expected for benzene: addition and cyclization reaction. It is a dehydrogenation product of benzene. If you remove these two bonds and put a bond here, that is triple bond. Now it is electrophilic in nature, neutral, unstable, formally neutral charged species. Okay. Is it aromatic or not? Yes. So it is aromatic in nature. Aromatic in nature. Strained molecule actively involved in nucleophilic addition and cyclization reaction. It is aromatic in nature. Aromatic in nature. And if you see the structure, see, this is benzene. Here one electron is present. Here one more electron is present. Now what is the hybridization of benzene? Benzene having hybridization sp2. It is not sp. Remember, all carbons having sp2 hybridization only. Okay. So sp2 and this molecule is a complete planar molecule. It is planar molecule. And see, there is a hybridization overlap takes place between these two adjacent sp2 hybrid orbitals. So we can say it is sp2 and here sp2. So there is a weak overlap between two sp2 adjacent carbons is observed here. It is not a strongest overlap, it is a weak overlap. And this triple bond is not a real triple bond. Okay, this is not a real triple bond. It may have a choice to move one part to other part. So don't believe this triple bond. This triple bond is a tentative triple bond. It can have a tendency to disappear out. So the triple bond formation takes place due to sp2 overlap. This sp2 is overlapping partially. It is not a strongest overlap. That's why there is a formation of a triple bond. So when you will expect triple bond here, triple bond formation is due to weak overlap between sp2 carbon. Between sp2 carbons there is a weak overlap is expected. That's why it is a triple bond which a adjacent overlap is very weak. It is a weakest overlap. It is not a strong overlap, it is weak overlap. It is ready to break. So that hybridization is not going to be involved in calculating hybridization of this carbon, this overlap. Triple bond formation is due to weak overlap between sp2 sp2 carbon. Okay. Now, if you take a carbon-carbon triple bond, this is normal carbon-carbon triple bond whose IR value is 2150 centimeters inverse. It is IR stretching frequency. IR stretching frequency for normal triple bond is 2150. Okay. And if you compare the triple bond present in benzene, this value is very less, 1846 centimeters inverse, which indicates that it is not a real triple bond. Okay. It is a partial triple bond which have a tendency to break readily. Okay. And how many pi electrons are delocalizing in this skeleton? Benzene having 6 pi electron delocalization. Only 6 pi electrons are delocalizing, not 8 pi electrons are delocalizing. 6 pi electrons are delocalizing, and this molecule follow 4n plus 2 pi electron rule. If they follow 4n plus 2 pi electron rule, it is found to be aromatic in nature. So when benzene is given, say it is aromatic. IR stretching frequency value it is 2115 centimeters inverse is IR stretching frequency. So this is normal triple bond present in benzene. So this triple bond is not a real triple bond. You can say it is not a real. Now go through preparations. Preparations of benzene. First one. This you can prepare by taking a aryl halide. See, this is called aryl halide. Here bromine is present. Now what I am using? I am using a soda amide. Soda amide is NaNH2. When I take soda amide, see, this hydrogen is taken by this base and this will migrate here and bromine will be removed. It is a concerted reaction. Loss of hydrogen, loss of halogen takes place simultaneously. So this is responsible to give a triple bond like this. This is benzene. Remember, base is almost all every time soda amide only. When soda amide is given, this will take this proton and forms a triple bond, halogen is removed. Clear? So, in that particular case, remember it should be a halogen. See, here I am taking a halogen, that may be any kind of halogen other than fluorine. It may be a iodine or it may be bromine or chlorine. Suppose if I want to take fluorine, this reagent is not suitable, there we should use lithium OMC. So suppose if I use butyl lithium, THF, then what happens is this will take proton from here and this will be removed out. It is not possible with this base. Fluorine cannot be removed by using soda amide. Finally, your answer is remain same, carbon-carbon triple bond like this. If you want to prepare a benzene by using a fluorobenzene, definitely we need to use lithium OMC. And if you want to prepare a benzene with the help of other halogens, best reagent is soda amide. Now this is called a E2 reaction. It is E2 reaction. So what is E2 reaction? Bimolecular elimination where hydrogen and halogen takes place simultaneously, but it is not a E2 reaction. So this is called E1CB. I will explain later. This is E1CB. It is a step-by-step process, conjugate base elimination, but this is a bimolecular elimination. If you remove bromine, iodine, chlorine other than fluorine, all halogens you can remove other than fluorine by using E2 reaction. But in this one it is E1CB. Only fluorine is E1CB, that too lithium base only, not with soda amide. Clear? These two you remember. In case of iodine, bromine, chlorine, E2. In case of fluorine it is E1CB, unimolecular conjugate base elimination. It is a multi-step reaction, two-step, but it is concerted. This I will explain in chemical reactions. One more time it will come. Clear? How many electrons are delocalizing in benzene? 6 electrons are delocalizing. Is it aromatic? Yes, it is aromatic. Is it triple bond present in benzene is a real triple bond? No, it is not a real triple bond. There is a weak overlap between two adjacent sp2 carbons, so that bond is only tentative bond. Okay, they have a tendency to give 1, 2 biradical, 1, 3. Okay, like that biradicals are going to form 1, 2, 1, 3, 1, 4 like that. Why? Because it is not a real triple bond. Okay, so next, see this is well known. One carboxylic acid I am giving. This is carboxylic acid and this is amine. Anthranilic acid. This acid name is called anthranilic acid. When anthranilic acid on treatment with HNO2 in water, so then what happens? See, there is a formation of a diazonium, nitrogen triple bond, and here carboxyl ion formation will take place. Aryl diazonium carboxylate. What is this? Anthranilic acid. Orthoamino benzoic acid is called, what is this? Anthranilic acid. This name is important one. Orthoanthranilic acid. Orthoanthranilic acid. Anthranilic acid on treatment with nitrous acid gives, what is this? Aryl diazonium carboxylate. So this aryl diazonium carboxylate is slightly heating. What happens is spontaneously they will undergo loss of carbon dioxide and N2. When loss of carbon dioxide takes place, there is a formation of triple bond and there is a loss of N2 and there is a loss of CO2. That is the answer. Now we prepared benzene or not? Okay, like this you can expect. Anthranilic acid on treatment with HNO2 followed by thermal decomposition will give benzene, N2 and CO2. Clear? Next. So I am using a thalloyl peroxide. Next one more is thalloyl peroxide. This is O, C double bond O like this. This is called thalloyl peroxide. Thalloyl peroxide. Peroxide of phthalic acid. Okay, this is on photochemically decomposed. First what happens, see, this bond will migrate and this will attack over here now. So first what is removed here? There is a loss of carbon dioxide. After loss of carbon dioxide there is a formation of a lactone. This lactone is unstable. Now this will undergo back to back decomposition. After decomposition there is a loss of benzene and CO2. So this is asked in exam. The intermediate formed during decomposition of thalloyl peroxide to benzene. What is that intermediate? Lactone. Okay, this is asked in exam. In set exam this question is given. This is many entrances, this question is given. Many interconversions also this is helpful. Okay, anthranilic acid on treatment with nitrous acid followed by heating, that will leads to form benzene and loss of N2 and CO2. Like this you may expect interconversion. So they will give like this. This is COOH and they will give NH2. So they may give HNO2 in water. Okay, that is A. After giving A, they will give thermal symbol and they will give B. A is nothing but diazonium derivative, B is nothing but benzene. This interconversion you remember. Thalloyl peroxide to benzene. Intermediate is lactone. This name you remember. This name also very important. Statement they will give. They won't give structure. Thalloyl peroxide on photolysis gives a benzene which proceeds with an intermediate of lactone. Like that statement they will give. Lactone, amide, okay, they may give acid halides, then followed by any nitrile, like that they may give 4 options. In that one, only cyclic esters are nothing but lactones, that is intermediate. This is thermal decomposition of, this is called Benz thiazole, benz thiazole, 1,1 dioxide. This is one more intermediate or one of the heterocyclic compound which can have a tendency to give benzene. This is on photolysis. You may expect migration of this and this will be transferred. So loss of N2 takes place and there is a loss of SO2. That is the answer. What is the name of this molecule? Benz thiazole 1,1 dioxide. That is on photolysis gives benzene and N2. Names are very, very important. Okay. Next, see, this molecule is most important one. It is called sulfur attaches to oxygen and see there is a trifluoromethyl sulfonate. This is called trifluoromethyl and here see this is sulfonate. Now this part is called triplet part. Trifluoromethyl sulfonate. This is called triplet part. Triplet, TF nothing but a triplet, that is up to here. Okay. Now this reagent on treatment with LDA, lithium diisopropylamide at minus 78 degrees centigrade of temperature. Now this hydrogen is get removed by this base and this will be get removed. Okay. Now finally what is the answer? There is a formation of triple bond like this. Trifluoromethyl sulfonate anion. Okay. So this is called triplet. Remember? This is C double bond O anion part. So this is represented by like this TFO minus. TF nothing but triplet. In your examination this is most important. Trifluoromethyl sulfonate. Sulfonate, this one. Sulfonate, total will be sulfonate. What is LDA? Lithium diisopropylamide. It is a harpoon base. It is only base, not a nucleophile. It is only base. Next, I am using one more. See, this is one of the molecule that is a trimethylsilane, TMS. What is TMS? Trimethylsilane. When trimethylsilane attaches to adjacent of triplet, TF, this one or not? This part is written here, OTF. Now this is on treatment with tetrabutyl ammonium fluoride in presence of THF. You remember this one, tetrabutyl ammonium fluoride, TBAF nothing but tetrabutyl ammonium fluoride. Okay, tetrabutyl, this is that structure, tetrabutyl ammonium fluoride. Now this reagent is a powerful reagent to replace silicon. If this reagent is given, definitely they will target silicon only. Now this fluoride, in this one fluoride will attack on silicon. Now this bond will migrate here and this will be removed. Okay. So desilylation, removing silicon by using TBAF is nothing but a desilylation reaction. Means we are removing, what we are removing? Silicon. Silicon is get removed by using tetrabutyl ammonium fluoride. Why? Because silicons are very strongly reactive with high electronegative elements. Fluorine is high electronegative or not? So it is effectively reacts with fluorine, then followed by chlorine, then followed by oxygen. It is a reactivity order of which one? Silicon. Silicon reactivity order. Silicon, it is exist in the form of, how it is exist? Trimethylsilane, like this. If this particular group is presented anywhere, it is a target for fluorine. Fluorine will directly attack on silicon and silicon will be breaks this bond and it is removed in terms of trimethylsilyl fluoride, trimethylsilanol, trimethylsilyl alcohol, like that. Some selective fragments are going to be removed here. So this is called TMS, trimethylsilane. TMS nothing but trimethylsilane. Benzene they won't give directly in your syllabus actually, but definitely question is compulsory from this one. So why? Because many areas will be there, especially in Diels-Alder reaction, it can involve in Diels-Alder. Diels-Alder is a pericyclic reaction. That's why they won't mention separately benzene. Okay, so be careful. So you should know about the structural properties as well as chemical reactions of benzene. Clear? Now see, this is called ine and this is called diine. What is this? It is ine. Ine means triple bond. Now what is this? This is called diine. Diine means two triple bonds are present. Now this is under thermodynamically or photochemically you can participate them. Okay. Now they undergo cycloaddition. Here 2 pi electrons are involving, here 2 pi electrons and here 2 pi electrons. Okay. Now first partner using 2 electrons, second partner using how many electrons? 4 electrons. So it is a 2 pi, 4 pi cycloaddition. What is this? Ine, diine cycloaddition. It is pericyclic reaction. Now triple bond becomes double bond. Now this becomes double bond or not? Now here the single bond becomes double bond. Now this triple bond becomes double bond. Can I write like this? Now this carbon connected here and this carbon is connected here. Now this is called cumulates generally. Cumulates, twin diene, twin triene like that. Twins or twin diene, cumulates nothing but carbon shared by 2 double bond. If carbon shared by 2 double bond, they are called twin diene or twin triene. Okay. Now this is highly unstable. Carbons are vertical or not? So it is highly unstable. They undergo bond dissociation like this. So this bond will migrate here and this bond will migrate and this will transfer out. So finally you will get this answer. See, here it becomes a double bond. Now here also double bond. How many carbons are present exactly? See here carbon, carbon, double bond, double bond. Between from here to here how many carbons are present? 4 carbons are not. 1, this is 1, next here it is 2, next here followed by 3, and what about this? 4, right? 1, 2, 3, 4, 1, 2, 3, 4, double bond becomes single bond, this double bond becomes triple bond and this becomes single bond. What is this? Benzene. It is benzene only. Other way of writing benzene. This is called ine diine rearrangement. Clear? Now this is called Benz triazole. This is nitrogen double bond and here one more nitrogen and see this is hydrogen. So this is on reacting with amino sulfonic acid. This is a amminating agent. Amino sulfonic acid. Now what happens? See, nitrogen hydrogen is get replaced by this group. Nitrogen nitrogen double bond and see this nitrogen is get aminated. This aminated Benz triazole is going to react with lead tetrastate. This you remember. This is called LTA. What is this? Lead tetrastate. And that will spontaneously decompose and gives benzene. So loss of N2 will take place back to back in this one. So here see there is a loss of N2 takes place in this one. So this nitrogen will be removed out and further they undergo dehydrogenation followed by elimination. So finally here you will get benzene. So this is generally done by using a Benz triazole. Benz triazole on treatment with amino sulfonic acid gives amination on nitrogen. Later on treatment with LTA, lead tetrastrate, that will undergo formation of benzene followed by loss of N2. Here step by step process, it is actually, it will take like this. This will migrate here, this will take over here now. Okay, so this will carry which charge? Negative. That negative takes one of the proton. Later on this hydrogen with bond and this bond migrate here and this hydrogen will be removed out. Finally N2 will be removed. Mechanism is not required, just you write this. Clear? Now this is last one. See, this is bromine and I am giving chlorine. Whenever, if I treat with magnesium in ether, dry ether, what happens? Formation of grignol or not? When formation of grignol takes place, here see, can write methyl magnesium bromide or not? This is chlorine. After getting grignol, this carbon becomes which charge? Negative, and this is positive. This will migrate here, chlorine is removed. So finally what is the answer? There is formation of benzene here. I am taking a aryl halide on treatment with magnesium, gives a grignol, adjacent carbon is removed in terms of Cl minus, finally forms a benzene. With lithium OMC also it is possible. Clear? So that is preparations of benzene. So these benzene preparations are most important. So you may expect in your exam, at least you may expect at least one interconversion from intermediate to benzene and from benzene to any pericyclic reaction. Clear? Next. Chemical reactions. Chemical reactions of benzene. Now chemical reactions are most important, especially they involve in two types of reactions, only two types. One is benzene is electrophilic in nature, they can have a tendency to involve in nucleophilic addition. Later on, benzene having a triple bond, it is ready to break, they want to reduce their strength, so that's why they also undergo cycloaddition. Especially in cycloaddition, they may involve in 2 pi 2 pi, one more is 4 pi 2 pi cycloaddition. Only two reactions are possible. Nucleophilic addition, one more is cycloaddition. Right, write that points. Benzene involve in two types of reactions. Benzene involve in two types of reactions. First one, benzene involve in two types of reaction. First one, nucleophilic addition. Second one, nucleophilic addition. Second one, cycloaddition. Nucleophilic addition. Second one, cycloaddition. That is nothing but cyclization. Okay, cycloaddition. First one, keep heading, nucleophilic addition. First one is nucleophilic addition. First reaction, nucleophilic addition reaction. See, this is most important one. Remember, whenever if any halogen directly connected to benzene, okay, then they will give definitely soda amide. This mechanism you remember. If they given soda amide, prepare up to benzene. Below if they given liquid ammonia, then one more time amination reaction. So when soda amide is given, adjacent to halogen is going to be get deprotonated. If it is a chlorine, bromine, iodine, simultaneous process. This I explained already. So here if halogen is, what is that halogen? If that halogen is iodine or bromine or chlorine, what happens, see, this amine part will take this proton and this halogen removal takes place simultaneously. Loss of hydrogen, loss of halogen takes place simultaneously. So this is called E2 reaction. So after getting this, what happens, see, there is a formation of a triple bond like this. After getting this triple bond, what happens, one more amide unit in ammonia. Okay, so in this one second equivalent will attack here, this is first possibility, and one more, it may attacks over here now, second possibility. Suppose if they attack here, now these pi electrons will migrate here or not. So after migration, what you will expect? This is NH2, and what you will expect? Negative charge. This negative charge is going to react with ammonia molecule. This is NH3, ammonia. That's why they will give soda amide in liquid ammonia. On that time what happens, see, this will take proton from here and what is removed? NH2. That NH2 one more time attacks on benzene. So this is one of the initiation step. Now finally what happens, see, can I write one NH2 group here? This is NH2 and here what? Hydrogen. Clear? Now this negative ion will take hydrogen from NH3. It will take hydrogen from NH3 and becomes NH2. Right? Now the question is, why I am attacking here, why not here? Is it possible to attack here? Yes, it is also possible. Suppose if I attack here, then what is your answer? Will you get same answer? You will get same answer. It is not possible to predict. Clear answer. Suppose if they put any isotope here, like this if they put isotope. Star is nothing but isotope. Now here you will get isotope. Same isotopic carbon, amine will be added. Now here also your final answer is amine. Can I expect one more answer? Yes. Now one more amine is very closer to that isotopic carbon. Can I write like this? This is the answer. Now you will get mixture of two equal possibilities. Now this is 50% and here also 50%. Suppose if this isotope is not given, it is impossible to identify. Clear? This reaction is very important one. How they will give in your exam? Soda amide in liquid ammonia. If they given soda amide, you restrict reaction up to here. Okay? If liquid ammonia is given, then only this negative ion have a tendency to take this proton and forms a aniline. We are converting a chlorobenzene, bromobenzene to aniline. Okay, that is your first reaction. Just see. Suppose if I take in place of other halogens, I am replacing with a fluorine. Now what happens? See, if I take soda amide, no reaction. Then definitely what should I use? Now I am using a lithium OMC. Lithium OMC in THF, this will take proton from here. If they take proton here, first what happens? See, anion formation takes place. This is anion. This is a conjugate base or not? It is a conjugate base of this acid. And very important thing is, this is very fast here. First step is fast step. Now here loss of proton in first step is observed, then loss of anion takes place in second step, it is observed very slowly. Now what you will expect here? There is a formation of a benzene here now, right? Now benzene formation takes place in how many steps? 2 steps. First step is a loss of proton, second step is a loss of halogen, second step is a slow step, so that's why second step is a rate determining step. This is called RDS, rate determining step. In rate determining step, how many molecules are involving? Only one. That's why it is called unimolecular conjugate base mechanism. This is only unimolecular, but this is E2. Loss of hydrogen, loss of halogen takes place simultaneously. But in this one, it is a step-by-step process. First step is a fast step, second step is a slow step, finally forms a benzene. After this, what they will give? They will give liquid ammonia. Suppose if they given liquid ammonia, what is your answer? Your answer is, finally can I write like this? This is NH2 like this, aniline. Any substitutions are given here? Any substitutions are given within this molecule? No. There is no substitutions, only bromine, only chlorine, only fluorine. So next I will show some examples where some substitutions are present adjacent to halogen, how to predict the answer. Take this. If isotope is given, mixture of two products are possible. If isotope is not given, only one product is possible. Clear? Now see, I will give some substitutions on aryl halide and you try to predict the answer. See, this is very important questions. If benzene question, if they want to ask, they will choose from this area. So see, here I am writing a methyl group, and what I am writing here now, ortho to methyl I am written bromine. Now what they will do, they will give soda amidine, liquid ammonia, like this they will give. So then how to predict the answer? First, where you will get benzene? Bromine carbon, adjacent hydrogen is there or not? Yes. Here there is no hydrogen. So definitely we need to remove from here only. So after removing hydrogen from here, so we will get triple bond here or not? Okay. So after getting this, you will get triple bond like this. This is one triple bond. Okay. Next. Now on which carbon can I add amine group? Can I add on above carbon or below carbon? Now that depends upon stability of anion. Okay. Suppose see, if I attack on above carbon, if NH2 attacks on above, if they attack on above, where you will get negative? Negative will come on this position or not? This will carry negative. Suppose if they attack on below, if this NH2 will attack on the here, where you will get negative? On above carbon or not? So if they attack on above, you will get below. If they attack on below, they will come on above. Now see, now anion is very closer to donor or away from donor? Now this anion is away from donor, but anion is very closer to donor. When this kind of anions are present, they are localized anions. Is it localized or delocalized? Localized. It is not delocalizing. Why? Because when triple bond loses its triple bond character, and that will attain negative charge on one of this carbon, and on that carbon you will get a negative charge, it is not a delocalized, it is localized. When negative charge is delocalized, we can apply mesomeric effect. Whenever if it is localized, we need to apply only which factor? Inductive effect. We need to apply inductive effect. Here try to apply only inductive effect in this example. Why? Because whatever negative charge we are getting, that is not present on nucleus of benzene. It is present on one of the carbon of benzene. So it is not delocalizing, it is localized. So always write down negative charge away from donor. See, negative charge is closer to donor, but negative charge is away from donor. So what happens negative charge if it is very closer to donor? Negative charge and donor, what happens? Unstable. So now see, this is stable or unstable? This is becomes unstable. Why? Because negative charge is very closer to donor. Donor and already excess electrons are there. These excess electrons are destabilized by donor. But here excess electrons are present, but they are far away from donor. So finally which is major? Above is major or not? This is CS3 and here it is amine. This is major and this is minor. So like this you need to remember. This is CS3 and this is NH2. Clear? This is found to be major. This reaction is very important. You need to know whether it is major or minor, which is preferred, which is not preferred. Here try to operate. Here key point is the negative charge present on carbon is a localized negative charge. For localized charges apply only inductive effect, don't apply mesomeric effect. Mesomeric effect operated on that charges which are delocalized. Right? It is not delocalizing. This negative charge not under conjugation with this one. This double bond is conjugate to benzene pi electron. They are delocalizing like this, one of the carbon carry outside negative. See the difference. Listen. See, this is benzene. Now this negative charge is present. This negative charge conjugate with this double bond. Now it is delocalizes. But this negative charge is never delocalizes. Be careful with this two. This and this both are not same. This charge present on benzene carbon. This is not present on benzene carbon. It is conjugate to benzene carbon. In this case, what happens is benzene pi electrons involved in delocalization. So suppose if it is positive, it is involved. Even if it is positive, it is localized only. You can write negative, negative or positive, positive, what it may be. If positive charge directly present on this carbon, localized. Adjacent of benzene carbon, delocalized. Whether it is present on benzene carbon or adjacent to benzene carbon? Benzene carbon, that's why it is localized. Any localized charge always apply inductive effect. In this one, inductive effect has been operated. Those who don't know whether it is delocalized, localized, those who know only try to write donor and withdrawing group away from positive charge as well as negative charge like that. If you know only that points, you will choose this answer. There is a problem with these options. Okay? Right. Why it is unstable? You should write reason. Negative charge is closer to donor. Now it is stable. It is away from donor. That's why it is stable. It is important example. You should know what is the role of that group on sigma bond. Soda made in liquid ammonia. This is asked question in exam. Like this they given. What is the answer? Now you should know about what is the role of methoxy. It is a donor or withdrawing group? It is donor for benzene. It is not a donor for benzene sigma inductive effect I am saying. You are saying donor according to mesomeric effect. But what I am saying, try to operate which effect? Inductive. According to inductive, methoxy group is a withdrawing group. Don't operate mesomeric effect. Okay? See, it is giving electrons to benzene pi electrons or not. But what I am saying, apply only the sigma bond I am saying. Don't give electrons to benzene, no use. Even if they give electron, no use. Why? Because charge present on outside. It is not present on inside. So here also same answer. See, it is withdrawing group or not? Now here what you will get? Triple bond or not? Now can I create negative charge very closer to withdrawing group or not? Now can I write amine here? Now this is the answer. If you create a triple bond here, if I attack here, here will get amine. If I attack on here, at this place you will get. If I attack on this carbon, here you will get which charge? Negative. Negative charge is very closer to which one? Withdrawing group. Here you will get negative charge or not? So now what is the role of this group? Withdrawing. See the arrow. I am concentrating like this only. Why? Why? Because we are not operating mesomeric effect here. Mesomeric effect is not exist in this one. Why? Because it is present only on outside carbon. But it is a mesomeric group. That is right. It is a mesomeric group. But we don't want mesomeric group right now. So now this group having two character. It is a plus mesomeric and minus inductive. It is a plus mesomeric, minus inductive. Ignore mesomeric. Now it is a minus inductive group. Finally we can add at this place. Will you give answer for this? Here I am writing nitro. You know very well nitro is a electron withdrawing group. NaNH2 liquid ammonia. So here remove this hydrogen. Remove this hydrogen and bromine, give the answer. Always negative charge should be closer to withdrawing group and it is away from donor. If I remove this one, will get same answer. Here this is nitro. Can I write here NH2? Yes. Why? Every time you need to think like this. I removed one hydrogen and bromine, I am getting a triple bond. If I attack here, negative charge very closer to withdrawing. That is stable. Clear? That is stable among this. Now, try this and give the answer. Here I am giving CS3 and this is bromine. Okay? Now, sodamide in liquid ammonia. What is the answer? Here OCS3. Now here I am giving bromine. Sodium in liquid ammonia. Soda amide in liquid ammonia is different. Sodium in liquid ammonia is different. Sodium in liquid ammonia if they given, that is called Bridge reduction. Soda amide in liquid ammonia is given, that is benzene mechanism. Be careful. This question asked in exam, this one. In CSR, this question is given. Ortho, bromo, anisole and reacts with sodamide gives product. So they given even bridge product also in that one. If you not observe this molecule clearly, you will select bridge product, bridge reduction product. So be careful. This will give a amination reaction. So where should I add amine group here? Can I add on meta position? Yes, here you should add. Why? This negative charge should be away from donor. Now here, can I attack on para? Yes. If I attack on para, what is the answer? Para amino anisole. Now here you will get negative charge or not? Is it negative charge very closer to this carbon? Yes. Right or not? If I remove this hydrogen and bromine, you can remove left side or right side, nothing will happen. Both are symmetric. If I remove this hydrogen and bromine, here you will get triple bond. After getting triple bond, this amine will attack on this carbon, here you will get negative. That negative is very closer to withdrawing group. Why? Because I am operating which effect? Inductive. Whenever if you operate inductive, only see the length. Don't see the conjugation. Only length. Okay, here also only length has been operated. This symbol if I write, try to operate only inductive. Don't operate mesomeric on that one. If this concept is given, operate only inductive. Based on this technique only, try to predict the answer. So that is amination on benzene by using sodamide in liquid ammonia. Okay. Next, this is one pericyclic reaction, cycloaddition. Cycloaddition reaction. Okay. See, if I take benzene. Benzene involved in two types of reactions. Benzene involved in two types of reactions. Benzene have a tendency to involve two types of reactions. First one is 2pi cycloaddition. Second one is 2 pi plus 4 pi cycloaddition. So 2 types of addition reactions are expected for benzene. 4 pi 2 pi, 2 pi 2 pi. Okay? 2 pi 2 pi, 4 pi 2 pi. 4 pi 2 pi is nothing but Diels order. This is Diels order. But what about here? 2 pi 2 pi. So first we will discuss some examples on 2 pi 2 pi, later on 4 pi 2 pi. 2 pi 2 pi cycloaddition. 2 pi 2 pi cycloaddition. Now remember, benzene having one triple bond or not? This triple bond is not a real triple bond, it is suffering from strain. This molecule is highly strained. It is a neutral electrophile, highly strained molecule. Okay, they are ready to participate in reaction to reduce their triple bond character. So if I take a double bond here now remember it is a 2 pi 2 pi cycloaddition reaction, 2 pi 2 pi more favorable under photochemical. This I will explain pericycle. 2 pi 2 pi more favorable under photochemical, 4 pi 2 pi more favorable under thermal. Okay. Now these pi electrons will migrate here, this will migrate here, and finally what happens? There is a formation of double bond like this. Okay, here 2 pi electrons I am using, and here how many I am using? 2 pi electrons. Finally forms a cyclic 4-membered ring adjacent to benzene. It is approximately equal to Peterno-Buch reaction, PB reaction, Paterno-Buch reaction, but in Paterno-Buch we use carbonyl compound and olefin. Okay, in this case we are using one unsaturated moiety. Now double bond, and I am using a cyno. If I use cyno, photochemical, if they given photochemical symbol, means he was asking what? 2 pi 2 pi. Now cyclize this and migrate here, and finally what is the answer? Double bond, and here it is cyno. Now can I use triple bond here? If I use triple bond, see, carbon triple bond I am using. How many pi electrons should I use here? Here 2 pi and here also 2 pi. 2 pi 2 pi. If they use 2 pi 2 pi, what is your final answer? Now here we will expect double bond, and this. That is the answer. Suppose if any adjacent partner is not given, sometimes what happens? See, they won't give adjacent partner. So what is the adjacent partner of this one? Triple bond. In this one, double bond. In this one, double bond. Sometimes adjacent partner is not going to be given in your examination. What happens when benzene is not given with a adjacent partner? So they undergo self dimerization reaction. If partner is not present, every 2 benzene molecules undergo dimerization, and you need to identify this molecule. This I given somewhere. You need to identify this. Somewhere I given. In concept of aromaticity, I given concept of aromaticity. Benzene on dimerization gives benzidine. This is called benzidine. Okay, what is this? Benzene. Benzene on dimerization, that will give benzidine. Remember this molecule name, benzidine. Benzidine is aromatic in nature, and see, it looks like a 4-membered ring or not, middle. I given a word of iutex opposition. If a molecule have a tendency to show 4-membered and aromatic ring character, so we need to prevent this 4-membered property. Why? Because 4-membered property is anti-aromatic, but still it is aromatic. But what happens, you should write clearly like this. It is not a correct resonating structure, it is destabilized resonating structure. This is correct one. Double bond, like this is correct structure. This and this both are same, but this is highly stable, this is a little bit less stable. Why? Because middle you are getting a cyclobutadiene type of structure or not. So it is anti-aromatic or not. So that's why this is less preferred resonating structure as compared to this. This is called benzidine. So this word you remember, benzene on dimerization. When dimerization is possible? When adjacent partner is not given. Benzene on dimerization produce, that will produce benzidine. Benzidine. This is called benzidine. Benzene on dimerization produce benzidine. Names are very, very important. This molecules helps in pericycle. Benzene also involved in 2 pi 2 pi under which condition? Photochemical. Remember, in your examination they won't give 2 pi 2 pi, they will give only photochemical symbol. If they given photochemical symbol means you are ready to do 2 pi 2 pi. Okay, be careful with this. Only two reactions are possible for benzene, 2 pi 2 pi in pericycle, 2 pi 2 pi, one more is 4 pi 2 pi. 2 pi 2 pi possible under photochemically, 4 pi 2 pi possible under thermal. If benzene given adjacent thermal symbol is given, go for Diels order. If benzene is given adjacent photochemical is given, go for 2 pi 2 pi. So why, I will explain in pericycle. In pericyclic theories will be there. Frontier molecular orbital approach, perturbation molecular orbital theory, orbital correlation theory is there. There I will confirm why Diels order is preferred under thermal condition and why this 2 pi 2 pi preferred under photochemical. Evidence is there. There I will explain. Actually this concept belongs to pericycle. You should know. Once if they are given photochemical symbol, you are in a position to predict the answer. Clear? Clear? Now second one, 4 pi plus 2 pi cycloaddition. Four pi plus 2 pi cycloaddition. Now see in this one. Now we know whenever if you see this, generally you will expect Diels order only. It is Diels order reaction. Diels order reaction is favorable under thermal condition. Photochemical it is not preferred. It is preferred only under thermal. Now how many pi electrons you can participate in benzene? Only two. Only two. Now they will give definitely one diene and dinophile. Now what is this? This is a diene. We need to use this 4 pi electrons and here we need to use 2 pi electrons. So this is called dinophile. Diene and dinophile. So in Diels order reaction, benzene acts as a, in Diels order reaction, benzene acts as a diene or dinophile? Dinophile. It is not acts as a diene. It is a diene partner. Diene means how many electrons should be participated? 4. So it is a 2 pi partner and what is this? 4 pi partner. Thermodynamically, what we are doing now? 4 pi, 2 pi. First partner what I am using now? 2 pi. Second partner is 4 pi. It is also represented in one more way in pericycle. Pi square, pi to the power of 4. This is supraaddition, supraaddition, suprafacial, suprafacial. Later I will explain. Kahn mode of rotation, disk mode of rotation, supra interaction, antra interaction. Later I will explain. No need to worry. Just right now you concentrate what is diene and dinophile. It is a diene. Now it is dinophile. Dinophile. How many electrons are contributed in adduct formation? What is adduct? What is adduct? What is adduct? When two are attached together and forms only one product, that attached product, single product is called adduct. Adduct nothing but addition product. Attached product. Two persons are attached together. Very fastly they are coming and they are fixed together. They are called adduct. Adduct nothing but addition single product is called adduct here now. See, this is migrating now. Now here see, how many pi electrons are participating now? 4. This will migrate here and this will transfer like this. Now you will get this product or not? Can I write double bond, double bond? Now here, can I write oxygen in middle? I am putting double bond like this. Can I write like this? This is Diels order addition product. Now after this they will give H plus. This is one interconversion. So when proton is added on oxygen, what happens? Now see, this is oxygen and double bond and here hydrogen will be added. Now this is plus. Okay. later on what happens, see this bond will migrate here now. So if this bond will migrate, otherwise you can open like this. If I open this bond, why? Because oxygen carry positive charge. So this is not acceptable. When bond is opened, now here what you will get? Here you will get positive charge or not? Now this is going to be stabilized by concept of aromaticity, migrate this, transfer this. And finally see, this is the answer. After removal of proton, this is your final answer. This is one of the best interconversion for your examination. Alpha naphthol. What is this? Alpha naphthol. When benzene reacts with furan under thermal condition gives A. If that A reacts with H plus gives B. What is that? AB. AB is this, A is this, B is, what is this one? Alpha naphthol. Will you write the Diels order product here? Thermal, like this they will give. Will you write the answer? Which is 2 pi partner? First one. This is 4 pi partner. Migrate and transfer here. So can I write like this? Double bond, 1, 2, 3, 4, and here 1, 2, and this. Can I write like this one more way? Is it right or wrong? One more way of writing. See, this is benzene. Benzene is combined with double bond, next double bond, and here double bond. Anthracene. So what is the Diels order product in this one? Which diene is participates in this one? Middle. Why? Because remaining two will attain aromaticity. So can I write like this? This will migrate here, touch here. This will migrate and this will transfer here. So here you may expect this product. Now here you may get a double bond. Now here you will expect double bond, and see these two are connected to which one? Benzene. So you can write like this. This bond is migrates and this will attaches over here. And this will migrates and this will attach here. Here this is pH and this is COOH. So now Diels order reaction is possible. So you migrate here, attack here, and this will migrate and this will attack here. Give the product. Diels order product in this one. Write clearly. So those who are familiar with pericyclic reactions or little knowledge on pericycle, you can write Diels order product very easily. So can I write a double bond between these two? Right. Now here, this I am connecting and this is nitrogen, this I am connected like this, right? Now these two are get connected. Now can I put double bond here? Now here nitrogen, nitrogen, double bond I am writing, these two are connected like this. Now here pH, pH, COH. Is it right? Now this is not survive, it is a one kind of elimination reaction. Now this bond will migrate and finally it will remove like this. So after this you may get this product here. This is your final answer. Double bond and this is nitrogen double bond and this is pH and this is pH and this is COH. What is this molecule? Isoquinoline. Loss of N2 takes place. What is this? This is called retro Diels order. This reaction is retro Diels order reaction, reverse reaction. Diels order exactly reverse is called retro Diels order. That's why thermal condition two reactions are possible. Thermal Diels order reaction, and one more is retro Diels order reaction. Use quinoline. Same temperature, two forward backward reactions. So listen, see, this is diene or not? Diene. And what is this? Dienophile. Now whenever if I go Diels order, now this will combine here, this will combine and this will migrate out. Now see, here you may get a new bond or not? This is new bond, right? Here also new bond and here double bond, right? Now which two bonds are formed here? These two. Now these bonds you can break like this. You can break this and you can break this and you can break like this. New bonds we are breaking and we are preparing a diene and dienophile reversibly. So that's why backward reaction is called retro Diels order. Forward reaction is called Diels order. See the arrows. If this molecule is given, you can prepare diene and dienophile in case of retro Diels order. Now these are the new bonds which are formed here or not? These are the new bonds. Here there is no bond, here no bond. Now we are creating new bond. That new bonds we are breaking. Here also we are breaking new bonds or not? Here there is no bond. Actually pi bond is there. That pi bond is disappear out. New bond is formed. Here new bond is formed here like that. Here there is no bond. Clear? So that is chemical reactions of benzene. So that is end of benzene intermediate. Take one question. Benzene is over. All preparations and chemical reactions are given. Nucleophilic addition reaction is most important. And here also it is important, one more time, it will comes with many different examples in case of pericyclic reactions. You focus only first reaction, amination reaction. Right. See. Benzene is a dash. Benzene is a dash. Electrophile, nucleophile, option C. Amphiphile, option D, all. It is a electrophile. Benzene is a electrophile. See, in Diels order reaction, benzene acts as diene, dienophile, option C. Both A and B. Now it is solvent. How it acts? It acts as a dienophile. Next. Dimerization of benzene produce A, naphthalene, option B, biphenyls, option C, spirenes, option D, none. Dimerization of benzene produce. What is that? None, not spirenes. Spirenes are one carbon which is attached by remaining 4 other carbons. Spirenes are this one. Nomenclature, I think. This is spirenes. Chiral axis molecules. Spirenes are chiral axis. It will come in stereochemistry, but in nomenclature I explain these molecules. Biphenyls are nothing but, what are biphenyls? One bond is separates 2 rings, 2 aromatic rings. Biphenyls are different, benzidines are different. So what is the answer in this one? Benzidine. Take one question. This is last one. See, the major product involved in following reaction is. The major product involved in following reaction is. What is the major product involved in this reaction? This is OCH3 and here they given Br. Okay. NaNH2 liquid ammonia. This is CSR question with 4 options I am giving. Soda amide in liquid ammonia. Option A. OCH3 and here I am writing amine. Okay. So option B. This is called bridge product. Bridge reduction product. Option C, this is one more bridge reduction product. So this reaction, those who are known very well, they will also know about Rich reduction. Okay, so then option D, this one. So this is OCH3 and here I am writing amine. So answer is D. Like that they will ask question. So when this question is given, they will ask some answers regarding Rich reduction. Why? Because Rich reduction is sodium in liquid ammonia, this is sodamide in liquid ammonia, that is the difference. All right, one more, just repeat. The major product formed in following reaction is, repeat same. The major product formed in following reaction is. The major product formed in following reaction is. This is bromine and this is isotope. The major product formed in following reaction is soda amide in liquid ammonia. What is the answer? Soda amide in liquid ammonia. Okay. Now, here I am giving NH2. This is the one. Now B. Now C. B's are not. Only B is wrong. Both A and B are exist. Just now I given mechanism. Remove this halogen, put triple bond between this carbon or this carbon. On same halogen carbon, amine will occupy. That is one answer. Adjacent carbon also amine will occupy. That is second answer. Okay. So don't fix this molecule structure clearly every time. So don't think that this is a rigid molecule. Okay. So these two positions, you can use these two positions or these two positions. Now suppose if I use this one, here you will get amine, here asterisk. Amine asterisk. Okay. Suppose see, this is benzene or not? This is benzene. Okay. Now this benzene, one of the carbon hydrogen I replaced and I converted into bromobenzene. Out of these 6 carbons, which carbon hydrogen I removed? Here carbon hydrogen bond is present. Now my question is, I want to convert benzene to chlorobenzene. Out of this, which carbon hydrogen is preferred or which carbon hydrogen is removed to convert this molecule? All are preferred or not? So suppose if I write this one, is it same? Yes. You can remove here and everywhere you can remove. And finally your answer is bromobenzene only. Here also same. So when you get a triple bond, now if you attack amine here, adjacent is asterisk. Amine adjacent asterisk. Suppose if you attack on asterisk carbon, now asterisk carbon adjacent is normal lighter isotope. Okay. Now mixture of these two is possible. Answer is this. So that is end of reactive intermediates. 6 possible reactive intermediates we learn, starting from carbocation, carbanion, free radical, carbene, nitrogen, and benzene. And especially in reactive intermediates, first you learn preparations and chemical reactions. Preparations, chemical reactions are most important, so that you can easily understand molecular rearrangements as well as named reactions and pericyclic and even oxidations, reductions, etc. Okay. So Reactive intermediates are over. So tomorrow I will start molecular rearrangements. Okay, molecular rearrangements are classified into 3 types: cationitropic, anisotropic, radical. First I will introduce what is migrating origin, migration terminus, etc. That all I will introduce. Then I will start carbon deficient rearrangement, nothing but pinacol, pinacolone. Okay, we will stop here. Take a break. Hi, sir.